Well, that's not. Well, hold on. What do you notice first? You notice that it converges first?
Well, it says that in the instructions.
Oh, it's okay. I'm sorry, I cut it off. I didn't see that. It is. It's also alternating and it's going small, so you know it's going to converge. That's correct. But for me, when I look at it, I notice the alternating signs first. That's what I notice first, right? And then I see odd numbers 3, 5, 7. Starts with 1. Which one is that? Sine x. Because what do we know? Just tell me this. Someone raise their hand and just tell me, what does sine x come out to be, the Taylor polynomial for sine x? Who can tell me? James, what is it?
1 minus
Yep.
x cubed.
Yep.
Over 3 factorial.
Yep.
Plus x to the fifth.
5 factorial.
And so on.
Good. Nice. Okay, so this looks like sine of. Is it sine of -1 or sine of 1? 1. I think it's just sine of 1, right?
Yeah.
If the signs didn't flip, but it looks like the signs correlate perfectly, right?
Yeah.
The sign. Oh, is this wrong then?
Yeah. Start with X.
Oh, so it, hold on. Yeah. No. Which one is it?
It's still X because X.
I understand, but what is the Taylor polynomial for sine? What we wrote was X. It does start with X. Nice. So now, yes, you plug in 1.
In this case,
It comes out to be the same thing because we're plugging in 1. Boys, face forward. Turn. Keep turn. Good. So sine 1. So this right here is the Taylor approximation for sine 1. Nice. You just found out that this right here is the Taylor approximation. That is sine 1.
So basically, just define
You have to match it and then say, this is a Taylor series that we know evaluated at something. What is it? Okay, hold on. Sean first.
So basically 34 is going to be like e to the x.
Yeah, that's going to be e to the something. What is it?
So like 2.
I think it's e squared, right?
Yeah.
Yeah,
Oh, I see. Oh.
I think it's e squared. They just want you to recognize this is e to the x. If this, what would this be? If it, what is e to the x? What does e to the x start with?
X.
It's 1 over. It's 1 plus x plus
X squared
over x 2 factorial, right? So we have the square right there, right? Yeah. So it's to the 0 power, to the first power, to the second power. It's 2. It's e squared. Yeah. Hold on. What does this almost look like?
A binomial series.
It looks like, so we're in binomial land, right? We need to factor something out though. What do we need to factor out?
Square root of t.
Well, you want to be able to make it. You want to make it 1 plus something, right? So if you pull the t out, what are you actually pulling out? You're pulling out square root of t. So this becomes the square root of t times 1 plus h over what? T to the what power? To the 1/2.
Why do
You do that because well, first of all, t is a constant, which we just established by checking on this thing. But t is a constant. So now this, first of all, Tori, the first thing you know is this right here. That's just along for the ride. That just sits on the outside. What we're really just expanding, we're just expanding this right here. That's all we're really concerned with. That square root of t is just along for the ride. It's just going to sit on the outside. We now need to expand this, and we can expand that because what do we know? Someone can answer this for me. We know 1 plus x to the p. Can someone tell me what that expands to? James Borden, what does it expand to? We go to next. P minus 1, p minus 2, all over 3x, like this, right? So here's the thing. We have that, right? But in this case, what does x equal?
H over t.
H over t. And what does p equal? A half. So now it's a matter of just plugging that in and simplifying as much as you can. I'll just show you what the simplification is. If you do this substitute, it's literally substitution at this point. It's literally substitution. You end up, and somehow it's got to clean it up. It cleans up into this. This is as good as it gets. And usually they're hyper aggressive in this textbook about simplifying nicely. You end up with minus 1 over 8. Yes, the desk makes a funny sound. H over t squared plus 1 over 16 h over t cubed. That's what it simplifies to. You can work out the algebra yourself, but here the key thing is right here, everybody. The key thing is right here. You do this factors. You do this. It is a factorization, right? You're pulling out something. This is just along for the ride. So you do this expansion, and look still what's on the outside. The square root of t is just along for the ride. It's just along for the ride because it's a constant. You're just interested in doing everything you can to turn it into something that is really close. What's the annoying thing about p being a fraction?
It's endless.
It's endless, right? It never ends, right? If p is an integer, or if p is a positive integer, what ends up happening at some point?
0.
One of those p minus somethings turns to be 0, and everything else cancels, right? That's kind of cool. We did that, right? If p is a positive integer, it's really cool, which is neat because it's a really kind of advanced way to factor. Anybody read Foxtrot?
Oh, yeah. Yes.
Jason's at the board, like the 10-year-old who loves math and science and all sorts of geeky stuff. He's at the board, and the question on the board is like, the box is 6 by 10
he goes on like
by 9, right? Like, what is the volume of the box? And he's sitting there doing this.
I was like
0 to 9, like dx, dy, dz. That's this right here is the expression for the volume right there. That is. It's a triple integral, right? All you're doing is scanning from left to right, up to bottom, left to right. 3 different ways. And the teacher's sitting there just like, ugh.